Hey guys, and welcome back to a new video and a little bit of a bigger project this time, since one of the most common requests I got for videos was to make a Bluetooth tutorial in Android. And this will actually be a playlist of 3 videos in which you will learn how you can make a Bluetooth chat. So you'll be able to connect to another Android device via Bluetooth and then send chat messages with each one. So as a quick demo, you can see I opened the app on 2 of my devices. On the one hand, we can see the devices we are paired with, and we can see scanned devices which are currently empty. If we click on Start Scan, then you will see that, the scan is started and it actually shows all the devices it can find in my environment here. Some devices don't have a name, which is why it's displayed as null, but this is a valid device. If we then want to chat with each other, then one party must start the server by clicking on Start Server. Then you can see it will navigate to the chat screen, and the other party then needs to connect to this device, which is in this case the Pixel 6. So we click on Pixel 6, which is already paired, and it will connect. Takes a little moment, and then we're connected. We can send messages, hello, send that, and you can see it will arrive here on the other screen as well. We can reply to that, oh, hello, and then we will see the message here as well. If the device is not paired yet, then instead both devices will get a pairing dialog, which they need to accept. So if they are paired, then they can actually chat with each other. If you then decide to disconnect by clicking on this little X here, then you will also see that the other party also automatically gets disconnected. So this is what we will build in the next 3 videos. In the first video here, we will implement the functionality to be able to see the list of scanned devices and to first of all initiate a scan, also to see the list of paired devices. So we will have these buttons to start a scan and stop a scan. The next video, we will actually deal with connecting to a device. So if we scan for devices, we can click on one of these and then actually pair with that device and initiate a connection. And then in the last and third video, we will implement the functionality to actually be able to send chat messages or to just exchange data using Bluetooth. One little note before we start with this, there are actually 2 different variants of Bluetooth. On the one hand, the normal Bluetooth, which we will use here, and Bluetooth Low Energy, so BLE. The difference is that the normal Bluetooth is usually used to exchange larger amounts of data, for example, if you need to send whole files or so, while Bluetooth Low Energy is rather used to have a long-lasting connection without draining any battery life. So if you have some kind of Bluetooth functionality and you don't need to exchange that much data, but you need to keep that connection alive in the background, then you should use Bluetooth Low Energy. This use case here for this chat app is rather a Bluetooth Low Energy use case, since exchanging these text messages isn't really heavy. So these are only small pieces of data. We won't use Bluetooth Low Energy here because this tutorial is just about the normal Bluetooth. And the way we'll implement this, you will also directly understand how you could use this to exchange whole files. I just want to mention this at the beginning, that the use case does not fit here, but it's really for the sake of this tutorial that you learn how to use the normal Bluetooth. And if you say you're really interested in Bluetooth and you liked building this app, then I'm very happy to also make a tutorial about how you can do this with Bluetooth Low Energy. And maybe a little note, you will need 2 Android devices to be able to test this. Of course, if you don't have these, you can totally follow through this playlist and learn how Bluetooth works, but it will probably be hard to try this out for you because I don't think you can actually use the emulator to test Bluetooth. I think the latest ones can do that, but I'm not sure how that worked. I tried it with the emulator and it actually did not show any scanned devices. I'm also not sure how you can test the data transfer logic via Bluetooth. I've read that the emulators, the latest ones, support that, but I haven't tried out how. So feel free to try around with that, but it's of course best if you have 2 Android devices, maybe yours and the one from a friend or so, and then it will work perfectly fine. So to be able to start with this tutorial, you first of all need some dependencies. And that's actually only the Dagger Hill dependency because all the Bluetooth functionality is already contained in the normal Android SDK. So make sure you have this class path here. You can also find the initial code in this video's description from my GitHub repository. And you need to make sure to have this Kotlin capped and Dagger Hill plugin for Gradle. And then down here, these 4 dependencies for just getting a Hill view model and the normal Hill dependencies. Other than that, we don't need any dependencies, so we can just jump into the video and start coding. The first thing is I want to create a model class that represents a specific Bluetooth device. Because what I want to show you here is not only how the Bluetooth stuff works technically, but also how you can integrate that into an existing architecture to follow clean architectural guidelines. So to have some kind of separation of concerns, to have a domain layer, a data layer where we will have the Bluetooth stuff. So you can also perfectly use this Bluetooth controller we will write in, for example, a view model while keeping the full flexibility with a local unit testing. So you could write a fake version of that for your test cases. I just think the normal Android documents don't really show you how you could take the code from there and integrate it in a nice style in your existing architecture, which is why I really want to show you that. So in our package, let's first of all create a domain package. And since this is all related to chat logic, let's call the package chat, in which we will put our Bluetooth device class. This will be a data class, and it will just contain on the one hand a field for the name, which is the name you chose in your device, which it is visible with during Bluetooth connections. So if you scan for it, just basically what you just saw in the list. And we want to also have an address, which will be the MAC address of each device. That's a unique address every single Bluetooth device has. And since the class that represents a Bluetooth device that already comes from the Android SDK is named exactly the same, and I think it's just the best name to represent such a device. Because of that, let's avoid any name complications here or conflicts by adding a type alias that this really refers to a Bluetooth device from our domain layer. And we can simply set this to our Bluetooth device here. Because as you just saw, there's also a Bluetooth device from Android Bluetooth, which we'll use a lot in this video playlist. But let's choose a type alias here that we can also refer to this class using Bluetooth device domain as a name. Next up, I also want to create another interface in this case in our chat package, which will be called Bluetooth controller. And this will really be kind of the heart of our application, since it really combines all the relevant Bluetooth logic. So it will contain the functionality to scan for devices. It will contain the functionality to connect to a device, to start the server. So it really combines this functionality and will expose it, in our case, to the view model. So let's choose interface here. And first of all, for this video, we are fine with having two state flows in here, which just represent the state on the one hand of the scanned devices and on the other hand of our paired devices. So we will have scanned devices, which is just a state flow of type list Bluetooth device. You can either choose this domain chat import directly, because in this class we don't need the Android one, or you choose your Bluetooth device domain name. That's up to you. We can copy this and have the same for paired devices, which is also a list of Bluetooth device. We then want the function to start the discovery, so to start looking for devices in your environment, and also to stop the discovery. And we want the function to release this, so to just free up all the memory and all the needed resources this Bluetooth controller will actually consume. Then next up, we will write the actual implementation of this Bluetooth controller, which will then make use of the classes we get from the Android SDK to just have our actual Bluetooth implementation. Let's go in our package and create our data package, since Bluetooth is of course data related logic and belongs in there. And let's actually also make a chat package in there. And in there, we will have an Android Bluetooth controller, which is a normal class, implements the Bluetooth controller interface like this, and it needs a constructor. In the constructor, all we need is the context, private val, context like this, and then we can hit Control-I, Control-A, and enter to implement all these different functions and fields. So first of all, for the scanned devices, what do we set this to? We want to have a private mutable version of the state flow, scanned devices, which is a mutable state flow, and it represents a list of Bluetooth device. Let's choose device domain here, since in this class we will use the Android SDK specific Bluetooth device class a lot. And we just set this to an empty list. Let's also replace these here like this. And we can then set the scanned devices equal to underscore scan devices as stateflow. So we also do these things in the view model, that we only expose the immutable version of our scan devices, since another class should not be able to directly modify our stateflows in this class. That way we really keep a single source of changes. And we then want to do the same for our paired devices. Let's paste this. Underscore paired devices. That's the same. And here we set this equal to underscore paired devices. Oops. As stateflow. Cool. Then, how do we now get Bluetooth related functionality? For that, we first of all need to get a system service, so a service that is provided from the Android operating system, which is called the Bluetooth Manager. And we can get this using a private val Bluetooth Manager by lazy. And then we use our context to call get system service, and we want to have the Bluetooth Manager class at Java. Then we want to have another lazy private val for the Bluetooth adapter. And the Bluetooth adapter is really, kind of the hardware module that contains all the functionality to, on the one hand, get your own MAC address, your own Bluetooth name, but also to be able to get a list of scanned devices, to get a list of paired devices, to initiate a scan, to initiate a connection, to start the server. So this will really be what we will use to implement this Android Bluetooth controller class here. So we say by lazy, and we get this from the Bluetooth Manager. We can call that adapter. And it's important, this adapter could be null, because if the device does not support Bluetooth, this will be null. So let's make a null check here and we'll be fine. Okay, so that is it for the initial setup in this class. One utility function we will use is one that I will write here, whether we have a certain permission or not, just a helper function. We pass the permission here in form of a string, and it returns a boolean whether we have that permission or not. Here we can return context that check self permission, pass our permission, and want to compare if that's equal to package manager permission granted. Because for using Bluetooth, you need a lot of permissions in Android. So there are a lot of different permissions depending on what kind of SDK you target. It is a pain, but to make that a little bit less painful, I use this utility function. And let's actually add these permissions to our manifest as well. Let's open that. And here we want to specify user's permission. On the one hand, we want to have the normal Bluetooth permission, which is only needed for the max SDK 30. So above that, this permission is not needed anymore. But then we need other permissions for more specific functionality. So for example, if we want to scan for devices, we need the Bluetooth scan permission, which we want to do in this video. Here we don't need this. But what we can use for this is attributes, user permission flags, this one here, and we set never for location because there is a little caveat here when it comes to Bluetooth and scanning for Bluetooth devices, and that is that under certain circumstances you can use a Bluetooth scan to determine the user's location, and that is why you usually also need location permission, which is kind of dumb because it's always hard to explain to the user, hey, this is a Bluetooth app, but please also give us your location permission so we can track you, which is always a bit dumb. To bypass this, there is this new flag, never for location, so that you indicate that, hey, this app really does not use Bluetooth for your location, and then you also don't need to declare this location permission together with the Bluetooth one. And then what you also might use is, for example, if you take a look, and just type Bluetooth, you can see there are a lot of permissions. In this course, in this playlist, we will use scan and connect, but you also have admin, advertise, and privilege. Maybe I get to these in another video, but let's for now, let's already add connect. Let's do that in the next video, so I keep these independent of each other. But one more thing we need is a user's feature, which is Android hardware Bluetooth. So with that, we just indicate that our app is a Bluetooth app and needs that hardware feature. So Google Play might not even show this app to devices that don't support Bluetooth. You also just saw there is Bluetooth LE, which is low energy. So if you're using that, make sure to add that feature instead. Cool. Next up, let's start with the simple stuff and go back to our Android Bluetooth controller. And the simple stuff is to actually get a list of paired devices. For that, I want to have a function, private function, update paired devices, which we just call every time we want to update the paired devices. We can very easily get these using our Bluetooth adapter, and we call bonded devices, which contains a set of Bluetooth devices, which is now the Bluetooth devices from Android. We want to call map to map these to our own Bluetooth devices. For that, let's create a mapper in our data class, the package chat called Bluetooth device mapper. And in here, we just call this function Bluetooth device, call this here on the Android Bluetooth class. We extend this to Bluetooth device domain. And since in this file, we need to deal with both our Bluetooth device classes, let's refer to the domain class instead. We can then simply return that. For the name, we just use, I think it's just called name as well. And the address is also just called address. And you can also see we get an error here because Android wants us to add a permission check. And it seems for this, it actually needs the Bluetooth Connect permission, which is kind of weird because you usually also want to show the name when you scan for devices already. So I'm not sure if the scan permission is enough, but let's add that. So to our manifest that we have it here, the connect one, we'll also request this then later. And then here it still complains because we don't have a permission check. We want to go to more actions and suppress this, because we will add our permission checks in this class here using this function, but Android is not smart enough to detect that we actually have this custom function here. So in here, we can say if we don't have the permission, manifest permission Bluetooth connect, then we just want to return. And then in this map block, we say it.to Bluetooth device domain. And we say that also, and here we want to call underscore paired devices, and we update this with a new list of devices. So we can say, here we get the new devices, and we update these with devices. We still get this error, so here we want to add this suppress annotation as well, not only to this function, but to the whole class, so we don't need to deal with this issue anymore, and then we don't get these warnings. Cool. So now we have a function to actually update our paired devices, which we can then call in our init block, update paired devices, and there we go. Next up, we want to implement the start discovery function to start scanning for Bluetooth devices. First of all, I want to check if we don't have the permission, manifest permission Bluetooth scan, because this is the one we need for discovering devices. If we don't have that, we simply return. And if we do have that, we now want to start the discovery. On the one hand, we also want to call update paired devices, and then we want to call Bluetooth adapter -- start discovery, and that will start the discovery. Seems simple, but how the heck do we now get, kind of the callback when a device was found with all the device information? So we can in the end just update our state here. This happens via broadcast receiver here in Android. So we need to declare that in our data package called found device receiver, make that a class, which will provide a callback on device found, which then passes us the Bluetooth device. Make sure to choose the Android one here. And this will be a broadcast receiver. So as soon as the Android operating system finds a device after we started the discovery, it will fire a broadcast, and to retrieve that broadcast, we can use this broadcast receiver. In here, we want to implement the onReceive function, which will then be triggered in that case. Rename this to context and this to intent. And then we can check when that intent.action, is actually Bluetooth device.action found. That will be the action that is attached when Android found the device. In this case, we know we can retrieve the device information. And we can do this also using the intent .get parse-able extra. So Bluetooth device here, this class is actually a parse-able, so it can be passed in a bundle or via an intent. And we can now extract that using get parse-able extra. The name of the extra is Bluetooth device.extra name. And the class is simply Bluetooth device ; class Java. You'll notice that we get an error here because this overload of this function is only available for API level 33 and onwards. So let's instead add a check here. This surround with if. So if that's the case, we want to actually call this overload, and else we call intent get parser level extra, and we use this deprecated one, which is just deprecated from API level 33 and up. So here we just pass Bluetooth device extra name. Then we have this device. We can check if it exists. So device .let, and if it does exist, we call our onDevice function, onDevice found function with this device. Then in our controller, we can create this receiver below our paired devices. So something like private val found device receiver is equal to a found device receiver. And here we get the callback with the device that was found. And then we can say scan devices that update to update our state flow. The new device we got is device to Bluetooth device domain. So we convert that to our main model, domain model. And then we need to update our list. Let's actually also give this a name of devices. So this will be the existing devices. And we now only want to add our new device to our list if it's not existing in there yet. So we check if new device is in our devices list. If that's the case, we just leave our devices list as it is, and else we update it with devices and we add our new device to that list. Right now, we don't do anything with this receiver. We first of all need to register it to actually get these results. And we do that in our start discovery function. So here we say context, register receiver. And here we need to pass our found device receiver and an intent filter. So with this intent filter, we basically specify the actions for which we want to register this receiver. In this case, we only care about action found, so it won't be triggered for any other actions. So we say intent filter, and the action is Bluetooth device dot, actually not this one, Bluetooth device, the Android one, dot action found. And let's actually get rid of this import by getting rid of this import. Because if we then scroll down, we can remove this and import this from the proper here from Android Bluetooth. And then in our release function, when we want to clear our Bluetooth controller, we simply call context remove, or to unregister it's called, unregister receiver, and we pass our found device receiver again, so that if we leave the screen, for example, we don't want to receive these results anymore. And then the last function here in this class for this video is stop discovery, which is simpler. We again check if we have valid permission, scan permission in this case. If we do, we return. I mean, if we don't, we return, and else we call Bluetooth adapter stop or cancel discovery. Cool. So that is it for our Bluetooth controller for now. Next up, we want to implement our view model. So in our presentation package that we can create here in the root package, we want to have a Bluetooth view model, and the job of the view model will now just be to interact with the Bluetooth controller and then map the result to UI state. So that will be a normal Android view model, Hill view model, since we want to be able to inject stuff in its constructor. So inject, import inject, and we need our private val Bluetooth controller in here. And since we have this abstraction, which sits in domain, that is totally fine to access this in your view model now. But if you were to use this Android Bluetooth controller directly in your view model, then you couldn't really write a fake implementation for that for your local unit tests, since you don't have an abstraction for that, which you could use for that fake version. Next up, we need a state. So in our presentation package, we create a class called Bluetooth UI state data class. And this will on the one hand contain a list for our scanned devices, list of Bluetooth device, make sure to use our import from domain, empty list by default, same for paired devices. And that is it for our state for now. We will extend this later. Let's go to our Bluetooth view model and actually have our state here First of all, a private val state is a mutable state flow of Bluetooth UI state, like this. Oops. And then we have a public exposed version of the state, which is equal to combine. So we now combine multiple state flows, which then triggers as soon as either of these state flows we pass here emits a value. So Bluetooth controller scanned devices, Bluetooth controller paired devices, or simply our state. If either of these values changes, we get the new values here, like this, and we can then map these to a new state. So in here we can simply say state, copy, and we pass our scanned devices for the scanned devices and paired devices for the paired devices. Oops, not that one. Like this. And of course we'll extend this later with more fields. We then want to call that state in, pass view model scope here, I'll explain that in a moment, sharing started while subscribed, passing 5 seconds here, and the initial value is the initial value from our state. So state in basically just converts this flow, which is just a normal flow, to a state flow, so it caches the latest value. It's basically the result here of this copy operation, and then it will just be a state flow, and we can observe the state in our UI and convert it to compose state. It will do that in view model scope, so it will launch the flow in view model scope. It will this code will be executed as long as there is a subscriber. So while there is a subscriber, if a subscriber disappears, then it will execute that for 5 more seconds, and this will be the initial value of the state flow that is created here. And the rest of our view model will be very simple. We just want to have a function to start the scan, which will be Bluetooth controller start discovery, and to stop the scan. Bluetooth controller stop discovery. And then last but not least, we can go to our main activity to implement the UI. Let's actually move this main activity in our presentation layer, call refactor, and then go to presentation, create a new package called components for our UI components. So what do we need on this first screen, so on our device screen? Let's take a look in visor here. I can close this probably right here. We on the one hand have a lazy column here that just shows a bunch of text, so paired devices, and then our list of paired devices and scanned devices with our scanned devices. If we click start scan, we want to call our view models function to start that, and stop scan, obviously the same in the view model. So first of all, let's annotate our activity with Android entry point to be able to inject our view model in this activity, and then we get that reference using hilt view model and passing the type. So Bluetooth view model. We can then get the state using by view model state collect as state, Alt enter to import that, and we now have that as a compose state. Then let's surround everything with a surface to give it a bit of a background. The color will be material theme colors background. And by the way, I haven't painted my theme colors yet, so if you want to have the same colors, I'll do that at the end of this video, and you can also just paste these from my GitHub. In here, we'll then have a when expression, which will extend later. I'm not sure if we can... Let's get rid of this when expression for now, because we will only have a single branch in this video. So in here, we'll basically just have our device screen, which we now want to create. So let's go to components, call that device screen, composable device screen. And we actually won't use any real navigation here, just for the sake of simplicity. So we won't use navigation library for this. We'll just show different composables based on our state. Of course, in a real app, I would always do that and use a real navigation library for things like having a backstack and being able to navigate back. But let's leave that out here. This device screen will get a reference to our state, Bluetooth UI state. It will have a callback when we click on start scan, on stop scan. And I think that's it for now. In here, we then basically just have a column. So this will be a column which on the one hand contains this lazy column as a first child, and then this button row as a second child. So column modifier is, modifier from compose, of course, fill max size. Then in here we'll have our device list, but let's start from the bottom to have a row of buttons. So create a row, fill the whole width. In this case, we can set the horizontal arrangement to space around to just evenly distribute them. The 3 buttons we will use here. First of all, I want to have a button to start the scan. Give it a text of start scan. And then we can copy paste this to have the same to stop our scan. On stop scan. Cool. And now we can implement our device list. So let's go to components and have our, let's put that in this file here. Just have a composable Bluetooth device list for which we want to pass our paired devices first of all. List of Bluetooth devices from domain. Then we'll have the same for our scanned devices. We'll have a callback when we click on a specific device, and we're going to get a reference to that. And a modifier as usual. Then let's have a lazy column for which we pass the modifier. And as a content, we first of all want to have a header, so an item, which simply says paired devices, like this. We can change the weight a bit, so font weight is bold, and the font size is, let's say, 24 SP. Alt enter to import SP. And I want to give this a bit of padding, so modifier padding 16 dp. Import dp, pressing Alt Enter. And then the next block will be an items block, since we want to display all of our devices that are paired. Select this overload here that allows us to pass a list. We pass our paired devices. We get each device here, and then we can simply show a text with the device.name. This could be null. We could either call toString to leave that text as null if it is null, or we could do something like no name or so. We then want to assign a modifier to this text. Modifier is modifier fill max width. We also want to give this a bit of padding, like padding 16 dp. And if we click on this, let's do this before the padding, so clickable. We call on click and pass the device here. We show this item 4. And then the rest is actually just the same for our scanned devices. So we can copy this code, paste it below, replace this with scanned devices, and this with scanned devices. We can then go back to our main activity, import device screen, pass the state here we get from the view model. On start scan will be view model, :start scan. And on stop scan will be the same, just with stop scan. Cool. I think apart from requesting the permissions, that is it. Let's do that next by just having a permission launcher. So permission launcher is equal to register for activity result. The contract is simply activity result contracts, request multiple permissions. And here we get the result, so our permissions, which you can now use to check if they were accepted or declined. Right away, I won't do any real permission handling here with showing a rational and things like that, because that is a whole video on its own, which I already have on my channel. So feel free to search for that and you will find how you properly do that. In this video, I'll just assume that the user will approve or grant the permissions we need here. This is one thing we need. On the other hand, we also want to have another launcher, which will be the Bluetooth or enable Bluetooth launcher. Because if the user does not have Bluetooth enabled, we want to show a dialog that they can do so. That will also be an activity result launcher, which you can use activity result contracts that start activity for result. That's what we can use for that. And here we actually don't care about the activity result. So we can just say something like this, a comment here, not needed. So if you want to check if the user actually enabled the permission after showing the dialog, you can use this result, but it won't have any use in our app. Then for our permission launcher, we want to check whether we can enable Bluetooth. So we first of all want to show the permission launcher, and then if they actually granted the permission, we want to show the enable Bluetooth launcher. So if the user does not have Bluetooth enabled, we want to show that after requesting the permission. And whether we can enable Bluetooth is, depending on if we accept the permission Bluetooth connect. If that's true, then we know we can enable Bluetooth. You'll notice that Bluetooth Connect permission is only available from API level 31 onwards. So we can check that first of all, cut this, check if build.sdk or build.version.sdk int is greater than build version codes that, what is it, R, I think? Oh no, it's S. Then we want to set it to whether we have that permission or not, and else true. Because if we are on an SDK lower than S, then we know we can always enable Bluetooth because we don't need this permission. And we also only want to do this, execute this launcher if Bluetooth is actually disabled. So we can simply go to our Bluetooth controller, copy these two classes since we also need these in our activity now, paste them up here like this. The context can be replaced with application context. And then we can actually have a variable here, private val is Bluetooth enabled, which is a simple Boolean. And for the getter, we simply set this to Bluetooth adapter question mark is enabled equal to true. If that's the case, we know it's enabled. So we can go down here to our permission result and simply say if can enable Bluetooth and Bluetooth is disabled, then we want to call our enable Bluetooth launcher and launch this with a specific intent. The intent can be created using intent and passing the action Bluetooth adapter dot action request enable. Cool. And then all we need to do is to execute this permission launcher when we launch our app. Let's use a launched effect block for that. So we just execute that once when we open our screen. And here we just check permission launcher dot launch. We request multiple permissions. On the one hand, manifest permission Bluetooth scan and Bluetooth connect. Both these require SDK 31, I think. Yes, so let's add the same permission check here, like this. And in that case, we want to execute the permission request. Otherwise, we don't need permission for Bluetooth, because this permission that we need below this is not a dangerous permission if we hover over this. So not a permission we need to request. It's a normal protection level, not a dangerous one. So yeah, we can just leave it. Google Play will show that, but we don't need to request it. All right. That was a lot of logic, a lot of Bluetooth, and a lot of pain. I actually just noticed that one thing is missing, and that is our Dagger Hill setup. So we just need to provide the Bluetooth controller we have here in the view model. So in our root package, let's first of all create a Bluetooth app class, which we need to initialize hilt, which is an application class. And we just annotate this with hilt and red app. And then we go to our manifest, add this as a name here. So in application, we say name and add Bluetooth app. And then we need to create a module, a Dagger module, in which we provide our Bluetooth controller. So new package called DI for dependency injection. And I have a full Dagger Hilt course. If I remember to link that, I will link it up here. So if you're new to that, feel free to watch this course. And this will be an app module, object, annotate it with module, and install in singleton components. So all the dependencies we provide in this module are singletons. So only one instance of these exists in our application. We're going to provide this with our function here, make it a singleton scope, and provide our Bluetooth controller. This will require the context, which we can actually get using application context in Hilt. Application context like this. It will return a Bluetooth controller, and then we return an Android Bluetooth controller. So I'm sorry if you're really new to Hilt, then feel free to ignore this stuff. This is not relevant for Bluetooth, but rather to just pass around your dependencies, so your classes like this in your project. But again, if you're new to that, watch my crash course on that and everything will make sense. So like this, I would say we now launch this on my devices and take a look in Visor. There we go, my pixel crashed, it seems. Maybe I'm missing something. Let's take a look in Logcat. And there we go, we get a stack trace, and the issue seems to be the lifecycle owner is attempting to register while current state is resumed. Oh yeah, I think I know what it is. We should not directly use this permission launcher in launch defect, because in onCreate this is not available yet. It should be in onStarted. But what we can do is we can take all this code and move it out of set content. Put it in here. The functions will be called the same. And in Compose, it should actually be remember for activity result. That was also an error. But let's move these outside. Also take this permission check and move it outside. So we just have our surface here, and we can then execute that directly in here. That's at least how I have it in my sample code. Let's launch these apps again on my devices and hope that works. On my OnePlus, it is actually requesting permission. My Google Pixel disconnected. It very much likes to do that. Let's try to reconnect. Now that's working as well. So let's hit allow on both devices, here and here. And you can already see, okay, this seems to not be the app. Let me relaunch this on my OnePlus. And this one is disconnected again. This is so annoying. I'm not sure if you have that as well on your Pixel devices, but if I use wireless debugging, it always disconnects without me doing anything. But in the end, we don't need both of our devices here to show the scan. So I'll just cancel this and leave my OnePlus, which is much more stable. You can see the button should actually be on the bottom. Let's fix that quickly by going to our device screen and assigning a width to our, oh, we actually don't even use this list. That's of course an issue. So for our device screen, let's go in that. And here for our column, we want to add our Bluetooth device list, pass the paired devices, actually state paired devices, state scanned devices, and here let's leave that empty for now when we click on that, and add a modifier of modifier filmX width and a weight of 1F. The weight of 1F will achieve that, yeah, our list will actually occupy all the remaining space except for the space our buttons need. Let's relaunch this, take a look here in Visor, and yes, that is looking similar to what I had before. We have our paired devices, which are already updating by default, and our scanned devices, which are showing nothing. But if we click Start Scan, we don't see anything, and we do get an error. The extra name expected parseable, but value was a string. Let's take a look in our parseable in our found device receiver. And yes, this needs to be extra device. I am very sorry for that. We can relaunch this. So simply replace this with extra device so it refers to the right thing. If we now click Start Scan, yes, now we get devices in here that are scanned. We see no name for those that don't have a name, and the real names for those that do have a name. If we relaunch this and stop the scan, then it actually stops scanning, and yeah, we don't see any more devices after that. So that is working fine now. It was a lot of pain to deal with this, and yeah, Bluetooth is just a big pain on Android. But in the next video, we'll then deal with connecting to one device when we click on that here, and to also pair with it when it's not a paired connection yet. And then in the third video, you will learn how you can actually transfer data from one device to another device to, in the end, be able to chat with each other. If you enjoyed this video, then you will definitely also love my advanced Android premium courses, which you can all find using the first link in this video's description. You will learn things like a multi-module architecture in Android. You will learn things like a clean architecture KMM app, so how you can make iOS and Android apps using Kotlin, and much more, so things like Canvas. Just check it out. I have a ton of courses there which are really advanced. And apart from that, I wish you an amazing rest of your week, and I'll see you back in the next video. Bye bye.